All right, so these are the notes for 2.2. We are doing properties of inequalities, and these properties are very similar to properties of equalities or equations when we solve them. We've used 1 through 3. The only difference is when we get to 4. So properties of inequalities. The addition property just says I can add one number to both sides. As long as it's the same number, I can add it to both sides. So that is, if I have A is greater than B, then A plus C will be greater than B plus C. I can just add some number C to both sides, and my inequality will still work. Now, this can work for, this is greater than, but it works for less than, it works for greater than or equal to, and it works for less than or equal to. So just as an example, if I say, okay, 3 is greater than 2, and I add 1 to both sides, that is 4 will be greater than 3. My symbol did not change, and it's still a true statement. So the subtraction property of inequality just states if A is greater than B, then A minus C will be greater than B minus C. I can subtract the same number to both sides, and my inequality will still work. So if I just do an example, if 2 is greater than -1, and I subtract 1 to both sides, I get 1 is greater than -2. That is still true. My symbol did not change, and my statement remained true. So for multiplication and division, the difference here is one of them is when you're multiplying or dividing by a positive number, and one is when you're multiplying or dividing by a negative number. So this is when C is positive, and this is when C is negative. All right, so if A is greater than B, then, and we have two different things that will happen. So for multiplication, I take A times C, it'll still be greater than B times C. Okay, so this is for multiplying. Well, I can still take A and divide by C, and it'll be greater than B divided by C, and that is for dividing. So my symbols do not change. They still equal, and this is when C is positive. So if I take 2 greater than 1, and I multiply by a positive number, so let's just multiply both sides by 3, I get 6 is greater than 3, and that is still true. My symbol did not change, and my inequality works. So if I do this for division, and I say, all right, 6 is greater than 4, and I divide by a positive number, so let's divide both sides by 2, I get 3 is greater than 2, and that is true. My symbol did not need to change, and everything stayed okay. So for multiplication and division, when C is negative, so if A is greater than B, then we have A times C will be less than B times C, and that's for multiplication. Our symbol did change because I'm multiplying by a negative number. And then for division, I have A divided by C will be less than B divided by C, and that's for division. Okay, when C is negative, flip the inequality symbol. Okay, so as an example, if I just take, here I'll just do the ones over here and just make things negative here. So 2 greater than 1, and now I'm going to multiply it by a negative number. So I'm going to say times a -3. 2 times -3 is -6. 1 times -3 is -3. If I left the symbol the same, that would say -6 is greater than -3, and that's not true. -6 is less than -3, so I needed to flip my sign. Okay, so that's why we flip it when we multiply by negative. And with division, okay, if I say 6 is greater than 4, but this time I divide by a -2, 6 divided by -2 is -3. 4 divided by -2 is -2. And I must flip my sign for my inequality to be true. All right, so turn over to the problems, 1 through 14. Number 1 says x minus 3 is less than 4. So I like to, when I'm solving these, draw a line down so I separate my two sides. And in this case, I need x by itself, so I need to get rid of the minus 3. So I'm going to add 3. If I do it to that side of that line, I got to do it to the other side. Okay, that makes these cancel to 0. X plus 0 is just x. My symbol stays the same. And I have a negative 4 plus 3 is a negative 1. Now to graph it, I just put some numbers on my number line here. At negative 1, I'm putting an open circle because it does not equal it. It doesn't have the line underneath my less than sign. And x is less than. So it goes that way. Okay, a way to remember that, if the variable's on this left side, my symbol points that way, which means my line will point that way. All right, and do the same thing for number 2. I want h by itself. So I'm going to add 3 to both sides. This is the addition property. Well, a negative 3 plus 3 cancels. We don't just put nothing. It's actually a 0. That's what happened over here. It still became 0, but x plus 0 is x. So I just didn't need to write it. But when nothing else is over there, you do need to put the 0. These cancel, so it's 0 plus h, which is h. My symbol stayed the same because I just added. Add or subtract, you leave the symbol the same. Now, I can go ahead and graph this. I have a negative 3, negative 2. I'm just putting some numbers on my graph. At 0, it's going to be an open circle because it doesn't have that equal sign. And 0 is greater than h, which means I'm going to graph to the left. Now, this time, look, it's not pointing that way. Well, that's because my variable is on the right. So this, if I want the variable on the left, I flip everything. And now it goes with. So you can write it either way, whichever way helps you graph. Now I'm just going to set up 3, 4, and 5 for you, and then you'll do 3 through 14 for the practice for 2.2. So I just want to point out that when we have minus and negative, remember it becomes plus a positive, so this becomes 3 plus 1 greater than or equal to 2. And then you go ahead and solve. That's not 3, I'm sorry. X. You're solving for x. X plus 1 is greater than or equal to 2. And then over here, if I were to draw that line, on this left side, I have more than just two things. I have a 6 and a negative 9. Those are like terms, so I'm going to add them together. 6 plus a negative 9, or just do the subtraction, 6 minus 9, is negative 3 plus u. Leave your symbol the same, minus 2. And now you can solve for u. Same thing with number 5. The left side only has the one term, so it'll stay. My symbol will stay the same. But now I have a 4c minus 3c, which is 1c plus 10. And now you can solve for c. So finish through number 14.